Today, our topic is about work and power, which is a subtopic of section energy resources and transfer over there. This was section 4, and it is lecture number 2 for energy and resources over there. And it was lecture number 3. No, it was lecture 2. Lecture 2. Okay. All right, let's move towards it. First of all, what is work? Work is basically, if I talk about work, work is basically if there is a body of any mass is lying on the surface over here, and I am applying a force on this body, and body is traveling some distance and now reaching at this point over there, then it has traveled some distance from this point to this point in the form of distance over there. Then I can say when a force is applied on an object through a distance and work is done on the object and energy is transferred over there. So if I say here mathematically representation, then I will say here work is equal to force multiply displacement. I use the word displacement over here, which means that I am talking about force multiply displacement. Both are vector quantities, but overall force is a vector quantity. Then I say work is equal to force as a vector multiplied displacement as a vector, but it is a scalar product because it is giving a work as a scalar quantity. Then we can write it W is equal to F D cos of theta. And if I say both are in parallel in same direction and theta is equal to 0 degree, then I say cos 0 degree is equal to 1, and my work is maximum when I say work max when both forces and displacement are parallel to each other. Then we say it is FD. If I say both are perpendicular, for example, you are walking on the road in this direction by carrying a bucket of water in your right hand over there, then both are making a 90-degree angle. In that case, theta is equal to 90 degree. Then we can say cos 90 degree is equal to 0. So your work will equal to FD into 0 will be the work minimum over there. That is a 0 work done over there. So overall, I will say to make something move, some sort of force needs to act on it, and um, the thing applying the force needs the source of energy like fuel or food if you want to exert on that. And whether the energy is transferred usefully, lifting a load, or wasted, you can still say the work is done. Just like a Batman over there, like that. Work done and energy transferred, and indeed one and the same over there. So I will talk here about the formula that was already written for you. If I write in the form of triangle for the formula over there, then I say W is equal to F multiply D over there. And if you want to calculate force over here, then divide work with the distance. If you want to calculate the distance, then divide work with the force over there. And it is the easiest way how to represent the work over there. And if I talk about, and the work is basically a scalar quantity because it has no direction over there, only magnitude plus unit also. And the unit of work is joule. If a force of 1 Newton is applied on a body and body travels a distance of 1 meter, 1 meter, then work done will be 1 joule. So this joule is the unit of energy, electrical energy, mechanical energy, electrical energy, and work, everything can be taken on the same behalf of there. After that, I will have to move towards power now. If I talk about power, then I will simply say here, power is basically a rate of doing work. Power is basically also a scalar quantity and having unit watt. And if I define it, what is power? Basically, it is a rate of doing work. Work is called power. Its unit is watt. If 1 joule work is done in 1 second, then work will be 1 joule. Then the power will be 1 watt. Power will be 1 watt over there. If I go for its mathematical representation of this power over this, then I will say power is equal to work done over time taken. Done over time taken. I can also represent this in mathematically form that power is equal to work over time. I can write it power is equal to F dot D over T. From D over T, I can say power is equal to force dot velocity can also be taken for physics over there. So 1, 2, 3. After that, I can also use according to potential energy, having the formula mgh over there. Then I can talk it about that power will equal to mgh over T can be taken into account for calculation of the power over there. After that, and now if I move towards kinetic energy and potential energy stores over there, then I will say, let's suppose there is a body which is moving, I'm moving towards kinetic energy. Kinetic energy, the energy possessed by a body, energy possessed by a body due to motion is called kinetic energy, measured in joules again, and is also a scalar quantity. Let's suppose I say there is a body of mass m moving with in this direction with the velocity v over there. Then its kinetic energy formula will be 1 by 2 half like mv square. This is the kinetic energy formula over there. If I say that a body is moving with some velocity and it is getting slowed down, then kinetic energy is decreasing, then it means there will be changes going to happen for that energy over there. On the other hand, if I go for gravitational potential energy or potential energy, energy possessed by a body due to energy possessed by body due to position, or we can say height, is called potential energy. For example, there is a body which is available from surface at some height h over there, having mass m. Then under the gravitational acceleration, we can say potential energy is equal to mass multiply gravitational acceleration multiply height. So potential energy is equal to mgh. You can manipulate these formulas of kinetic energy and potential energy for calculation over there. When you are saying that falling objects also transfer energy over there, falling objects transfer energy. In which form? I can say here that when an object is falling, then we can say energy will be lost. Energy lost from we can say uh, gravitational potential energy store over there or source over there. Store the energy is lost from this. Gravitational potential energy is equal to energy gained in kinetic energy stored. Energy gained in kinetic energy stored. So whenever an object is falling down, he is basically losing his gravitational potential energy and gaining in kinetic energy. So they are interconverting their energies and holding the principle of conservation of energy. Principle of conservation of energy is going to hold on over there. So, and in real life, air resistance acts against the falling objects and causes some energy to be transferred to other energy stores, and that is thermal energy of the object and surrounding should be lost over there. Now, I will have to move towards non-renewable energy resources and power stations a little bit. So, non-renewable energy resources, renewable energy resources. Resources means which cannot be reused again and again. Like we can say here coal, which I am using for burning and I am getting heat for different steam engines over there like that. Oil, like in the form of petrol, I'm using in my vehicles, that is non-renewable energy resource. Natural gas, which I'm using in our food cooking purposes over there. Nuclear fuels like uranium and plutonium. Nuclear fuels like uranium and plutonium, like that. So I can say these are all non-renewable energy sources. They will all run out one day. And I will say here about them. They will all run out one day when I'm using too much about them. And they all do damage to the environment. They all do damage the environment. These are some disadvantages of non-renewable energy resources over there. If I talk more about this, about but they produce most of our energy. Remember that? But they produce most of our energy. Over there. So these are the non-renewable energy resources which are present right now. So most powerful stations use steam to drive a turbine over there. And for example, how the turbine is being given with the help of fuel. I will say here that fuel is the chemical energy which is given to the boiler first. Fuel is providing energy by burning over there, producing heat in the form of boiler over there. And after boiler is given to this energy to boiler, and boiler is then producing steam over there, which is going to be transferred towards turbine, which is going to rotate over there. Let's suppose I'm saying the turbine is here, and turbine is going to be taken, and this turbine is going to produce electricity by rotation over there. And turbine is connected with a generator which will produce electricity over there. So this is the way how I can use the fuel over there, which is non-renewable, for the production of electricity, which is much more helpful for me to use this electricity in power station via national grid over there. But here I will say more about fossil fuels are linked to the environmental problems are directly over there. They also have some advantages. Advantages. If I'm using the fuels over there for the production of electricity, then I will say here, lots of energy relatively cheaply over there. Number one, lots of energy. After that, I will say here for number two over there that the energy of fossil fuels does not rely on weather, like renewable energy sources like wind and solar, like that. Solar panels are mostly consumed nowadays over there. So we can say that is not reliable on weather, not relying on weather over there. After that, he is saying there in at number three for the advantages, we have lots of fossil fuel power stations already, so we don't need to spend money on new technology to use them. Lots of power stations already installed in ours. But what are the disadvantages which are related to it? The main disadvantages which I will highlight here, that all the fuel vessels when they are going to be burned in the form of disadvantages, if I want to write that, then I will say here that these disadvantages can be taken out by the release of carbon dioxide gas into the atmosphere, which is causing the global warming and also responsible for climate change over there. Burning of coal, number one was global warming related to carbon dioxide. Number two, I will say here, burning of coal and oil releases the sulfur dioxide gas, which is responsible for acid rain over there, which is also very drastic effect on the wildlife and soils and harm trees over there. And a massive disadvantage is of using fossil fuel that they are eventually going to run out. They are not reusable over there. They are running out over there. They are going to finish over there with the passage of time. After that, if I will talk about nuclear, wind, and geothermal power over there. Then nuclear power are also used being in the nuclear reactors, wind turbines we are using, and geothermal power we are using over there. So first of all, I am saying here nuclear power, how I am using it and how I should use it to produce electricity over there. A nuclear power station is mostly same as to produce with the help of steam rods. Only the fuels, uranium fuel rods are being introduced over here. Uranium fuel rods. Uranium fuel rods are going on right now, and they are provided with a water resource over there, which is coming towards it. And it is also being provided inside in the form of production of steam over there with the help of this phenomenon, which is directly related to a steam generator over there in the form of complete phenomenon over there. Like I'm using here a turbine, which is producing a steam turbine over there. And I am joining it to this farm over there. And this farm is also going towards it. So steam out and return of water is being taken from this point over there. And steam to turbine it is going, and it is steam generator. Steam generator. And when steam is coming out from here, then I will say that this steam is going to fall on the turbine to produce moving it towards generator, and electricity should be produced over there. Then nuclear power stations are basically using nuclear fission. The difference is that nuclear fission is being used of uranium. Nuclear fission is a process in which heavy nuclei are broken with the bombardment of some small particle over there. This uranium particle is broken down to bigger krypton and barium atoms, plus 3 neutrons released also over there. And also a lot amount of energy is released. This energy is responsible for the conversion of water intake, which is coming as a cool water, and steam is being thrown towards it. And during this process, energy is transferred from nuclear energy stores to thermal energy stores by heating, and mechanically to kinetic energy stores, and finally transferred electrically through the national grid to the final electricity generated. And nuclear reactors are expensive to build and maintain. They are expensive to build and maintain over there. On the other hand, I can also say here, take longer startup than the fossil fuel ones. Processing of uranium before use, it causes pollution. There is always a risk of leak of radioactive material, or even major catastrophe like we can say Chernobyl over there. So we can say here it is very risky to store uranium over there. After that, I will say more about it, that I can say here a big problem with the nuclear power is radioactive waste that you always get over there. Waste material to be thrown out. Waste material is a problem with the nuclear power station over there. But there are advantages to nuclear power. It does not produce any of greenhouse gases. These were disadvantages related to nuclear power stations over there. Advantages. And if I go towards advantages, then I will say it is not producing any harmful gases. No harmful gases are produced by using the uranium waste. It does not produce any greenhouse gases which contribute global warming. Also, there is still a plenty of uranium left in the ground, and there is this was basically nuclear power to be going on to talk about it. After that, I will move towards wind farms. Lots of wind turbines are available, basically wind power. If I talk about wind power, then I will say a big blades are adjusted in the windy areas of high hills. Wind power involves putting a lot of wind turbines up exposed places like on moors and on coast or out at sea over there. Wind turbines use energy from the kinetic energy stored of moving air to generate electricity, and wind turns the blades which turn the generator inside. So we can say here wind turbines are available on the coastal areas or on the moors over there. Wind turbines are producing electricity by production of or rotation of armature inside the generator over there. And this effect is having wind turbines are quite cheap to run. They are very cheap to run over there. After that, we can say it is they are very tough and reliable, and wind is free over there. Mean it is a renewable energy resource. It is very cheap to produce electricity over there in this phenomenon. Wind power does not produce any pollution waste. No pollution waste is produced over there. After that, I will say here they are moving towards the wind is never going to run out. Never going to run out over there. So this was a benefit over there, but there are disadvantages. They spoil the view, like any scenery can be disturbed over there. These were advantages for wind power. If I go towards disadvantages, then I will say here, they are going to destroy the view. One man disadvantage. After that, another problem is that sometimes the wind is not strong enough to generate electricity. Speed of wind can be slow, not enough to generate electricity required according to the demand. And in the last, although the wind is free, it is expensive to set up wind farm, especially out at sea over there. It can be expensive to build up a wind farm over there to generate electricity. In the last, I am so going towards geothermal power over there. Geothermal power for the generation of electricity over there. If I am using it, then I will say here, this is only possible to certain this is geothermal energy over there. Then I will say here, let's suppose that this is the surface of soil. Below round about 7 kilometers, the surface of earth over there, you are going to pump down a cold water. Water is pumped down. At this point, when water will reach, there will be hot rocks, which are going to heat up the water in the form of steam, which is coming out as hot water over there, hot steam over there. Hot steam is pumped out. Then this steam is given to the turbine, and turbine is generating, connected to generator, and electricity is produced. So this generation of electricity, and after the end of this, it is transferred to national grid and distributed to the customers over there. So this is the whole way how it is going to work over there. But in some places, geothermal energy is used to heat buildings directly. This is actually brilliant, free, renewable energy resource with no real environmental problem. So we can say here as an advantage, I can say here that it is a renewable energy resource. Renewable energy resource. After that, I can say here, no environmental effect. No environment affected by it. We can also say that the main drawback is the cost of drilling down several kilometers. These were advantages. And if I go towards disadvantages, cost for digging over there. And we can also say that cost of building a power plant is often high compared to the amount of energy which we can get from out, and few places where it seems the economic option can be taken over there. So this was related to geothermal energy. And in the last, I will have to go towards solar and wave power over there, and then using electricity. In the next video, we will go for solar and wave power also, and we will also go towards generation of electricity using water over there. So stay connected and kindly subscribe my channel. Thank you so much for today, and like the video, share the video, and kindly subscribe my channel over there.